All right, we're going to take one more look at moles and mass and number of particles calculations. And so we've got our first question here: how many formula units of CaBr2, so that's calcium bromide, are in 2.10 moles? And then we've got what is the mass of 3.25 times 10 to the 22nd formula units of calcium bromide. So for this first problem, we want to think about what units do they give me and what are they asking me for, and that's how we decide which part of the mole relationship that we need, and then how to set up. So I'm given moles, I'm asked for formula units. Now formula units is another name for like a molecule, except we can't use the word molecule for things that are ionically bonded. So CaBr2, we'll learn about how we're supposed to know whether or not that's ionic or not. But for now, basically formula units, that's what you're supposed to call these particles. But just talking about a group of these, it's kind of the same idea as a molecule, except a little different. Okay, so going from moles to formula units. So I'm counting something. Notice there is no mention anywhere in this problem of a mass or grams. So if I'm counting something and I'm given moles, I need the relationship between those two things. So we're counting, so 1 mole is equal to, for the stuff that I'm counting, that's the Avogadro's number part of the relationship. So it's 6.02 times 10 to the 23rd. Now in this case, I'm told that this is the thing I'm counting. So we're calling those things formula units. So I'm not going to label this as an atom. I'm going to label it as a formula unit. So that's the unit of Avogadro's number. That's the name of the thing that we're counting. Okay, so set up, once I have the relationship down, 2.10 moles. These two numbers go in my conversion factor, one over the other. I want the mole to cancel. And so I'm going to put that on the bottom, and I want to end up with formula units. So 2.10 moles times 6.02 times 10 to the 23rd. Oops, 2.1 times 6.02. You're doing this along, making sure you're putting the numbers in correctly. And this number has 3 significant figures. Remember that trailing 0 counts when there's a decimal point. So 1.26 would be 3 digits. So if you get the numbers off your calculator, that's a 24. And so this is, the unit is formula units. Just because it's a weird, awkward, long word to put on there doesn't mean it's not a unit. It doesn't mean you don't need to put it there. So that's the unit, 1.26 times 10 to the 24th, formula units. Does my answer make sense? Well, 1 mole has this number of formula units. I've got twice that amount, a little more than twice that. So this number is twice that number, 1 mole. So yeah, that makes sense. Next problem. Now we've got what is the mass. So that's going to be in grams, right? Mass is our common gram will be our common mass unit we'll be working in. And this time we're given some number of formula units, big gigantic number. So I think about what's the relationship between those two units. Well, from the previous problem, still talking about the same stuff, but even if it wasn't, same relationship with counting the particles. There is Avogadro's number of formula units in 1 mole. The other part of this, though, is that I need to connect this to mass. So I need to know, well, what's the mass of this number of formula units of calcium bromide? Well, if it was just calcium, like in our previous videos, then it would be just the mass of calcium from the periodic table, which is 40.08. But we've got this whole formula unit. So just like we talked about in class, if I have 1 calcium and its mass is 40.0, this is from the periodic table. Looking at the subscripts for bromine, there's 2 bromines there, and that's 79.90. So if I add this all up, 79.9 times 2 plus 40.08, and that gives me 199.88. And this, though, again, for 1 mole, it's going to be this mass from the periodic table, except expressed in grams, because we're talking about not just one single formula unit, but rather this number of formula units. So it's the same way we would figure out the formula mass, except we're calling it a molar mass because it has units of grams, and that is for 1 mole of the substance. So there's my relationships. So this many grams equals this many formula units. So now I start my setup. So I have the 3.25 times 10 to the 22nd. I'm going to abbreviate that FU. Don't be offended. It's formula units. And then I want to set up my conversion factor. So I want to end up with mass units. So the mass is going to go on the top. So 199.88 grams grams on the top, and then the number that has formula units on it is on the bottom. So the mole unit itself, I don't need to convert to it. Again, you could break this up into two calculations where you convert from formula units to moles and then moles to grams, but these two things are also equivalent to each other, so I can just plug them straight in. So, watching our math on our calculators, we've got 3.25 times 10 to the 22nd times 199.88 divided by 6.02 times 10 to the 23rd, and I get 10.8 grams. And this has three significant figures in its base number, so that's why I'm keeping 3 there in my final answer. So again, I'm thinking about what did the problem give me in terms of units, what did they ask me for. If it's just relating moles and the count of something, so whenever I see a how many of a molecule or an atom or a formula unit, I'm just using this Avogadro's relationship with the mole. If I am asked about mass and counting particles, that's when I need to figure out molar mass. So if it's for a compound instead of one atom, then I would just add up the parts like we did in class, and that's the mass of that number of formula unit or molecule or whatever. And that is the last little type of problem you might encounter involving the mole.